was recently doing some edge retention comparisons on pine, looking at push cutting sharpness and push cutting edge retention. This is very different from slicing edge retention, typically done on cardboard or ropes. So the first thing I wanted to look at, of course, is the difference in steels. So I used AUS 6, Spyderco Vagabond, 9CR 18, which is a Chinese version of 440C, 10V, 64 Rockwell Peters, and plan on using other steels. And I'm going to give a link down in the description to the discussion thread so you can see lots of numbers and details about the exact specifics. I just want to hit a couple of highlights here. One of them was that initially, one of the things I also wanted to look at was there a difference between using a pure burnishing rod? I hesitate to use the word pure because very rare that something is usually just 100% one thing. This is a nitrided rod made by CKC Knives, Conley Harris, and it has a little bit of texturing on one end and the other end is completely smooth. So I was using mainly the smooth end. So what I would do is I'd take the knife, sharpen it. I was using a 300 grit Sweet Hero Ryu stone. Finish the edge then with the Spyderco Fine Ceramic rod at 15 degrees. Go to a whack of wood cutting and then burnish the edge very lightly on the nitrided rod. Repeat it, burnish the edge again, repeat it. And so I was looking at the degradation in edge retention from the initial edge to the burnished edge. And then I would do a very similar procedure, but instead of using the rod to burnish the edge, I would use the Spyderco Fine Ceramic when it dulled, repeat it, and then Spyderco Fine Ceramic again. So I was just hitting the apex 2 more times. And I was looking at then, was there a difference in edge retention with the Spyderco Fine Ceramic repeatedly versus using the nitrided rod repeatedly. And the interesting thing is, the first time I did it, I found that yeah, there was a big difference. The edge retention in the burnishing rod fell off almost twice as fast as the edge retention using the Spyderco Fine Ceramic. And the reason, of course, that made sense to me is because basically if you think about the edge, and so here's what an edge should look like, right? You should get a nice clean apex like that. Well, after you use it, the apex is all a little twisted and deformed and has these little bits and knobbles going from one side to another. So what I was figuring was that the Spyderco Fine Ceramic wasn't just straightening these things up, it was also cutting some of them off. It was getting rid of some of that fatigued metal. But the burnishing rod, of course, is not going to really cut any of these little knobs off. It's just going to push them back in place. So they're still going to stay there, but they're going to be like little knobs sticking out of the apex, and those are going to be weak and break off. That's sort of what I thought, a working hypothesis. However, the other thing that came to mind is that maybe one of the reasons why the edge retention is so low when you burnish it versus when you first sharpen it is because what you actually end up doing, so again, this is your sharp edge, very nice, very clean point. This is your worn edge. The points are all moved around and the apex is all higgly-piggly. So when you're burnishing, unless you use tremendously light force, I figured what might actually happen is you don't just take these little points and move them up straight. You actually end up bending them completely back the other way, and then you bend them back and forth the other way, and you just go back and forth until you mainly more or less average them out. And I was thinking, well, everyone has done that, little thing that you fool around with as a kid when you take a spoon and you bend it back and forth a bunch of times. You're like, hey, I can break metal with my bare hands. I'm Superman. Of course, it's fatigue causes the metal to tear. So I was like, well, what about if I tried to minimize fatigue? Now, I'm not going to argue this is practical, and it's obviously not, but I would burnish the edge of the knife, and I would go super, super light. And it was taking me between 100 to 120 passes per side, that's 200 to 240 passes, to get the knife back to shaving sharp again. That's not practical, right? You exert a little bit of force and you can get it back to shaving sharp in maybe 2 to 3 passes. But I was just going ultra light to see what would happen. And in that case, I was able to get the edge retention from the burnished edge to be similar to the edge retention from the Spyderco Fine Rods. Now, both of them were still degraded from the initial edge retention with the freshly sharpened edge, but using ultra light passes on the burnishing rod, I was able to make it perform similar to the Spyderco ceramic. Well, then I asked myself the next logical question: what would happen if I did ultra light passes on the Spyderco Fine ceramic? Again, this is not practical. I wouldn't argue that this is a sensible way to sharpen. It just takes way too much time. So again, take the knife, grind the edge on a water stone, set the apex bevel with the Spyderco Fine ceramic. Do a bunch of wood cutting. Then come back and just work the apex bevel again, do some more wood cutting. Just work the apex bevel again, do some more wood cutting. And what I found was, if I went ultra light, and just to show you how light I'm talking about, I used a little bit of water on the stones, minimize friction, and I was trying to just use the bare minimum force that I could keep the knife on the rod. Now this is barely making contact. I'm just trying to keep the knife on the rod. Now, if you've ever used a Spyderco Fine ceramic to touch up a knife, especially one which isn't like really blunted, just a little bit below sharpness, you'll recall that the sharpness will come back almost immediately. Well, this doesn't. It takes quite a long time. And this is again 9CR18, Chinese version of 440C, and I doubt it had anything fancy like an oil quench or that they use cryogenics, so I doubt it's exceptionally hard. Probably somewhere between, say, 55 to 57. And what I found, so with these ultralight passes, it often took me between 25 to 35 passes per side, so that's 50 to 70 passes, to get the knife back to shaving sharp. Now, is that sensible and practical? Probably not. But you'll slowly sneak up on the edge. It's probably starting to shave a little bit now. Right, okay, now. So it's just starting now to catch hairs a little bit. That's fine. So I am making some progress. So I probably got to do another 15 to 20 passes, and then it gets that really nice sharpness again, where it sort of catches the hair above the skin. But see how long it's taking. Well, the interesting thing is that I found when you do this ultra light sort of sharpening, you can maintain that level of edge retention. There's no drop off, or very little drop off. So with the initial edge, sharpen on a water stone, apex bevel on the Spyderco Fine, I'd do around, say, 1,000 or so cuts, and it would no longer be able to shave. If I used moderate force on the Spyderco Fines to just rework the apex, do that touch-up, as people like to call it, well, the edge retention would only be about 50%. And if I kept doing those touch-ups, the edge retention kept dropping. But if, when I went to do the touch-ups, I used really light force, barely made contact, I was able to get the edge retention to almost go back to where it was with a freshly sharpened edge. And there's two explanations that could be causing that. One of them is I think I'm minimizing the amount of extra fatigue I'm putting into the edge. And the other thing is I think I'm maximizing the rate of abrasion versus deformation. You'd actually need to do some microscopic studies of the edge to find out which of those was the contributing factor. But what's the point of all this? Well, I wouldn't argue again that this is practical. Like you're out, actually doing some work with a knife, the knife gets a bit dull, and you got to get the edge retention, get the sharpness back up again. Well, you just take the knife and you take the stone, you give it a few hard wipes, and you keep cutting. But at the end of the day, you're sitting down, you got some time, you want to put a final edge on your knife, and you have an extra, say, 30 to 40 seconds. When you're setting that final apex bevel, go as light as you possibly can. Go really light. Focus on just making contact with the apex. And you might see a difference in edge retention. I certainly did, and it was repeatable. Like I did this up 12 times now, and there's quite a large difference between using that feather light sort of touch and even, moderate amount of force, just a couple of ounces. Again, it's way slower. I'm not arguing that it isn't. It's much slower when you go feather light. But there is a pronounced difference in edge retention. And you also get less effects with carbide tear out when you go with higher carbide steels like 10V. The more force you put on the very apex, the higher the pressure and more fatigue, and I think that bending back and forth leads to more carbide tear out. So in repeated touch-ups where you're just hitting the apex, it tends to start creating little snaggles of chips which are coming out, and if you go ultralight, they tend to be minimized. So a couple of interesting effects, so you might want to do some experimenting with yourself.